Okay, next, to determine which tags are forcible, choose Forcible Tags from the Data Monitor Show filter. Note, you can only enable or disable forces at the controller level. You cannot enable or disable forces only for a particular module, tag collection, or tag element. And if you recall, when we were in the tag monitor or the monitor screen, we were able to sort on forcible items. Once we sorted on the forcible items, we all saw that that was only in the controller tag level when we had actually added the I/O module. So next we're going to go ahead and cover troubleshooting controller problems using Logix 5000. Next, then we'll move into configuring the analog cards and setting up a PID instruction. Then we'll talk about ISA symbols and examples using Logix 5000. And that's really important. There's a couple of things here. One, troubleshooting the controller problems. Really, you just, if a processor or a I/O problem is going to occur, it will fault the processor. And you got to say, okay, if this processor faults, am I going to have a problem? Is it going to create a hazard, or is it going to create a situation that will overflow something or something like that? And if that's the case, you really ought to start thinking about either hardwire control or a redundant type application where you actually set up two Logix 5000 processors or the Logix CPUs and do redundant applications, so that if you have one I/O rack or one CPU rack have an I/O problem or a CPU problem, it switches over to the other CPU. So typically I don't do redundant applications. I have done, I don't know, maybe 3 or 4. Primarily they're smaller machine control applications for offshore applications. So if the processor decides to fault, it faults, and then they call us up and we go ahead and fix it for them. So I don't really deal with it a lot. The things you want to watch for is sometimes on the PID instructions, if you switch your min position on your output, your min control variable, we haven't talked about PIDs, but if you switch those, the min and the max, you can fault the PID instruction and it'll shut the processor down. So there are ways that you can actually handle these faults and store them and keep part of your program running. It's certainly, I guess, a good idea to do this if you are unsure what is causing the fault. Typically, when I do a PID instruction, I know I'm going to get a fault when I first download the processor. Until I get the PID values at their correct range. If they're out of that range, it'll fault that PID instruction and shut the PLC down. On the ISA symbols, process engineers actually explain what they want you to build by showing it in ISA symbols. So they do piping and instrumentation diagrams. You sometimes say it's a PID, P and ID. It's not a PID, proportional integral derivative control instruction or control scheme, although it could be. But what they're doing is they're doing flow diagrams. They're showing you the flow and they're giving you these IS symbols. And each IS symbol is a key for you, because when you see a certain IS symbol, you know instantly in your mind, oh, I've got so many analog ins and so many analog outs and things of that nature. Or I know that this is a pressure transmitter, and usually 90% of the time you'll see pressure transmitters are 2-wire devices as opposed to 4-wire devices. So it actually tells you in your mind how your PLC needs to be wired up. And then finally, and as we've been going through this, we'll actually be drafting ladder logic for Logix 5000, so you do see hands-on applications. So first we have the CPU, and again you've got your key here. When it's in the middle position, it's in the remote position. Here's your program position, and here's your run position. So what you want to do is, after you've got this thing up and running, you're on the factory floor, go ahead and put it in run mode and pull the key. Now, you can actually create a fault. If you're downloading this processor and you're in remote mode and you switch it over to run mode, that'll, right during the download, you'll fault the processor, and you have to clear the fault and stuff like that. So we'll try and fault a simulator. I don't know if I can or not, but I'll try it. And if I can, then we'll actually clear the fault. If I can't, I'll just show you how to clear it. So again, when you're looking at these controllers here, you want to look at their indicators: the run indicator, the I/O indicator, the force indicator, the battery light, the I/O light, the RS-232, and the OK light. And these tell you what's going on. And the run, if the run is solid green, the controller is in run mode. If it's off, it's in program or test mode. And if your I/O is flashing red, you've got a bad chassis. So you want to watch for that. Now, when you get a brand new processor and you drop it in this rack, you're going to find out that that thing is flashing, right? And you're going to say, hey, what's going on there? Really, it has no firmware. So you want to go ahead and upload the firmware first. After you've uploaded all the firmware, then you won't have this flashing light. And I've run actually into a problem where I actually did have a bad chassis, and it gave me the same indicator that I had a bad firmware. Now, when you're downloading that firmware, don't touch anything. Make sure you've got a solid power source. You do not interrupt this, because if you're downloading your firmware for initially, it's called controlled flash, and we covered that in part 2, I believe. If you interrupt that, it will disable that I/O, and then you have to ship the processor back to Allen Bradley, and they have a whole service for this, and then they ship it back to you. So you don't want to do that. You know, I see a lot of people, they say, oh, it says don't hit this button, and they do it. I don't know why they do that, but don't do those things. Then you've got your force, and really what we're focused on here is your faults. So here you got your battery light, and you're OK. And so if you have a flashing red light on the, what was it, OK? Yeah, on the OK light, if it's flashing red, if the controller is then a new controller, the controller requires firmware. Okay, so if the OK light's blinking at you, you require that firmware, and you need to load it up. It might be a brand new controller, so you turn the key switch to program, to run, to program, go online with RS Logix software, and then you can actually download that. If it's solid red, the controller detected a non-recoverable fault, so it has cleared the project from memory. To recover, cycle power to the chassis, download the new project, change to run mode, and if the OK LED remains solid red, contact your Rockwell Automation representative or local distributor. And so that's the key. If this OK light's solid red and stays red, and you've tried everything, you need to get that processor. You can just swap it out. No, they'll actually send you a new memory module, and you install it, and then you put the old memory module back in a bag and ship it back to them. And I think the service is actually free. I know certainly if you have a support contract like we do. Okay, so if a fault condition occurs that is severe enough for the controller to shut down, the controller generates a major fault and stops the execution of logic. Depending on your application, you may not want all major faults to shut down your entire system. In those situations, you can use a fault routine to clear a specific fault and let at least some of your system continue to operate. I've never done this, okay? In real life, I've never done this. So if you really feel like you want to keep something running and you have a major fault, then you can follow these ideas. Choose where to place the fault routine. A fault routine lets you program logic to take specific action after a fault, such as clear the fault and resume execution. Where you place a routine depends on the type of fault you want to handle. Okay, so if you have the execution of an instruction fault, so like the PID routine, if you have an execution of an execution of an instruction fault, you're going to get a fault type 4, and you need to create a fault routine for a program. Okay, so if you have a communication with an I/O module fails, you have a fault type 3, and to handle this, you would create a routine for a controller fault handler. And for the next 4 items, you would create this control. So you can see all these items right here. To deal with them, you would do the same thing. You would create a routine for a controller fault handler. And that includes a watchdog for a task expires, fault type 6. While the program is downloading it to a CPU, the key switch is placed in run. That's a fault type 8. I guess this could happen. I usually tell everybody to step away. Keeps me from having these problems. And then if you deal with motion, if you have an axis fault, you'll have an 11, and you can handle that as well. The controller powers up in run or remote run mode. You'll get a fault 1. Create a routine for the power up handler. So again here on the first one, we have execution on instruction faults, which is probably one of the most common, I would think. To do this, you would go to your main program. Okay, so again, if we have to do a create a fault routine for a program, what we do is we go to the controller, My Controller, slide down to Main Task, go to Main Programmer, New Routine, and then we right-click on the program and choose New Routine, define the routine, and then we can assign the routine as a fault routine. So here we go, Properties, and we right-click on these on the program and choose Properties, specify the fault routine. So we'll say this main routine, fault routine, and say OK. And then to create a routine for a controller fault handler, we would go create a program for the controller fault handler. So you go to Controller Fault Handler, create a subroutine, configure the routine as the main routine for the program. So here you have controller fault routine, fault none, and you got to tell it what fault you would like to put in there. So create a routine for the power up handler. The power up handler is an optional task that executes when the controller powers up in remote run mode. Use the power up handler when you want to accomplish either the following after power is lost and then restored. Prevent the controller from returning to run remote mode. You leave the routine for the power up handler empty. When power is restored, a major fault type 1 code 1 occurs and the controller enters the fault mode. 2, when power is restored, take specific actions and then resume normal operation in the routine for the power up handler. Clear the major fault type 1 code 1. Enter the logic for the actions.